Okay, let's talk about the last bit of quantities and reactions. In this video, I would like to talk about dilution of solution. Now, before we move on to dilution, we actually need to find out the numbers of moles of solution dissolved in the initial solution. Now, it doesn't have to be the whole solution that was prepared. It can just mean that the initial solution that was transferred to, I guess, the bigger vessel to be diluted. That can be found if you follow this formula. Number of moles of initial equals to C initial times by V initial. So number of moles in moles, C is in moles per liter, and V is in liter. For you to find the number of moles that was in the final solution that was made, you can pretty much do the same thing. N equals to C times by V. If the moles of initial equal that of the final, the relationship can be C initial times by V initial. That equals to C final times by V final. So C1 times by V1 should equal to C2 or C final times by V2. Here's an example of what it may look like when you do dilution calculation. So 20 mils of 1.5 molar solution of NaCl was transferred to 200 milliliter volumetric flask, and distilled water was added to graduation mark. What is the concentration of the dilute solution in molar? So the question looks like this. Someone prepared 1.5 molar solution, regardless of how much this was originally volume-wise, but 20 milliliters of this solution was transferred to a bigger vessel, in this case 200 ml. 20 ml that was transferred would be 0.020 liter, so we use that. What you're asked to find out is the concentration of the final. Right. Let's use the formula that was introduced just then, but I'm just going to shorten it by writing C1 times V1 equals to C2 times by V2. Initial, final. Quite simple as that. Let's plot these numbers in. Concentration, initially it was 1.5 moles per liter, and you're multiplying that by 0.020. That equals to C final, which is what you're trying to find. So leave that as that, times by what you made up to, which was 200 milliliters. So you have to convert it to liters. So only thing we have to do now is to solve this for C2. Alright. So this whole thing here, 1.5 times by 0.020 over 0.200. As long as you can solve that, that'll be good. I might even multiply everything by 1000, so I can get rid of some of the zeros. Okay. And now I can start eliminating some of the numbers. 2 over 1, that will be 2. So this is just 1. Now it looks like 1.5 is over 10. That's into the final concentration. And that was in molar, or that's really the same as moles per liter. So there you go. Compared to the first initial concentration, 20 mil that was used in 200 mil. Well, it's really 1/10, isn't it? So 1.5 became 0.15. Okay.